Hello everyone. Today we are going to continue working on simplifying radicals. I know this is kind of tricky stuff and tough stuff. It's not something you just put in your calculator to get the answer for. So I know in our test next week, we're going to ask you to show your work right on the test. So make sure that you are really working at trying to get this. Go back and rewatch the first two videos. More times you see it, it might start to make sense the second, third, or fifth time. So this is a warm-up. I'm not going to do all of these, but I'll work the rest of them out in the notes. So when we go to the simplest type of simplifying radicals, if you were to type that in your calculator, you would get a decimal. We want the exact answers without any rounding. So what we're going to do is we're going to separate that 63, into two numbers that multiply together to get 63. Those are called factors. And one of them has to be on that perfect square list that you have. 1, 4, 9, 16, 25. Keep using that. Okay, and see what goes in there. Well, 9 goes in there. You use your calculator to figure out which number goes in there. I told you I would put a multiplication chart out and I forgot, so I will do that today. But we have 9 times 7 is 63. Then we use the product property. The product property says if you have two factors under the same square root, you can separate them and give them their own square roots separately. So then what we get for our answer is we get the square root of 9, which is 3, and then times the square root of 7. But we don't need that little times in there. That's understood. Okay? When it gets to variables, x squared, okay, is actually a perfect square. So what I like to do is the same thing I just did, is to separate that x to the fourth into perfect square factors of x squared. And then take the square root of each one separately. And that gives you the square root of x squared, which is x, and the square root of x squared, which is x. So then what you get is you get the square root of x to the fourth is x squared. So there is the rule that I put out yesterday, which basically says if you have an even exponent, you just cut it in half. If you have an odd exponent, like in number 3, then the even number, divide this by 2, and that gives you 1.5. So the one x comes out, and then the other x would stay underneath. And what we do with the number on this, remember, is separate it into the perfect square factors and take the square root of each individually, and that gives you 2, and then the 5 stays underneath. And we usually put the numbers first, so you're going to see it written like this. And number 4, you just multiply those things together under the same root. Multiply all that together. So that would give you 50. And then that would give you x to the 9th. And then do the same thing you just did on number 3. Okay? And again, that'll be worked out in Schoology. So here is your homework for today. It'll be in Schoology. And again, you should not be putting any decimal answers down, ever. Okay, during these next several days. You can use your calculator, but you should be using it for just checking to see what perfect squares go in there. So, going back to things that we knew how to do before. This is a fraction. 36 divided by 4, we can reduce that. That becomes 9 over 1, or simply 9. Okay, 18 over 3, okay, simplifies to 6 over 1. Or just 6. So let's take a look at number 3 is the same. Let's take a look at number 4. Well, what about the square root of 81? Well, we know that's 9 over 2. Okay, well, we can't simplify that anymore without getting a decimal or a mixed number, so we're just going to leave it. Okay, so that's what we're doing today, is we're working on what's called the quotient property, or the quotient rule. Okay. And you might not realize this, but I mean, you can cut these in half. This would be 32, and this would be 8. And then you can see that 8 goes into 32, so this becomes 4 over 1. So sometimes you have to reduce, and sometimes you have to simplify more than once. Just like when you reduce a fraction, if you didn't notice that actually 4 goes into each of these, or sorry, that 16 goes into each of those numbers. So if you would have just divided this by 16 right away, you would have gotten that this is 4 over 1, or 4. All right, so here's what we're working on. Okay, we're going to work on the quotient rule. And there's lots of notes, so you might just want to take these first notes down and then add to it. Okay, we have notes separated for each individual case. I like to look at it in general. So first of all, if you're simplifying something, you can see that you have this perfect square up here. Well, then don't do anything else except take the perfect square, the square root of 81, 9, write it over the other one and reduce if you can. Okay, or in the second case, you have a perfect square that's on the bottom. So again, what you're going to get is you're going to get 20 over the square root of 4, which is 2. Well, 20 over 2 can reduce to 10 over 1 or 10. So that's what the steps are, is when the numerator or denominator are perfect squares, you simplify that perfect square first. Then you simplify the fraction if you're able to, and then leave your answer as a fraction, or if it reduces like 20 over 2 to 10, that's fine. So let's work through a few of these. Well, the square root of 36, that's 6. You should be starting to get comfortable with these. That can't be reduced. 8 over the square root of 49 is just 8 over 7. Again, that can't be reduced. You can get a decimal for it, but we're not providing any decimal answers on this. 64 divided by 8. Well, the square root of 64 is 8. So we have 8 over 8, which is simply 1. And last but not least, this would be this 30 over the square root of 4, which is 2, which would equal 15 over 1, or 15. So it's pretty simple when you have a perfect square under the radical. But if not, then we're going to use what's called this quotient property. And it's kind of like the multiplication property, except if you have division under your square root, if you have two numbers divided under the square root, you can divide them separately. Okay, and so when you look at the square root of 16 over the square root of 49, you can separate those into the square root of 16 over the square root of 49. And the square root of 16 is a perfect square, that's 4. And the square root of 49 is also a perfect square, 7. So sometimes they work out really nice like that. So if you notice that the numerator and denominator, or one or the other, are perfect squares, then separate them and take the perfect square of each. We just did that. Then simplify the square roots, and then leave your fraction and reduce if necessary. So here I can see that sorry, I was just looking at something really quick. So I can see that one or both of these are perfect squares. So if one or both of them are perfect squares, just separate them. Just get rid of the squares if you can, and that's going to be 6 over 8, but we can reduce that fraction always. It's divide by 2 and you'll get 3/4. So those are the things we're doing, okay? I think these are pretty straightforward. I don't think you're going to have a lot of trouble with these. Like this is the square root of 121 over the square root of 100, which is 11 over 10. Now, sometimes just like when I started doing the multiplication property rule, I start figuring out like I don't want to have to rewrite the numbers, so I just put the square roots underneath the radical with them, and that's fine. Like this, instead of separating it into the square root of 25 over the square root of 196, then I just draw them in there. That's the only difference, and you can do it either way. Okay, so now the square root of 25 is 5, and again, if you don't have all these memorized, the square root of 196, okay, well then just type it in your calculator. But the square root of 196 is 14. Okay, all right. Last scenario. Okay, when the numerator is larger than the denominator and both can be simplified first, then reduce this like a fraction. In other words, if you can reduce the fraction under the radical, do it. But don't do it if one's a perfect square. And then you follow the same steps. So in other words, 20 divided by 5 is going to be just the square root of 4, which is just going to equal 2. Or you could write it as the square root of 4 over 1, which is the same as the square root of 4. Okay, so again, you can pause the video, kind of read through the notes, but I'm kind of combining it all together. So, none of these in number 13 right here, neither of those numbers are perfect squares. Look at your list. Keep looking at your list, okay? But I can reduce it. I know at least 8 times 7 is actually 56. So I can actually reduce this This goes in here once, this goes in here 7 times. So this ends up to be the square root of 7. We can't simplify that anymore, so we just leave it. In this next example, right here, number 15, I kind of jumped down instead. I can see that this is a perfect square. So is this. So I'm not going to try to reduce that, although I could. But the square root of 100 is just 10, and the square root of 25 is 5, which reduces to 2. Now, you could reduce that because that reduces to 4, and you're still going to get the same answer. So with the quotient rule, like in number 14, if you have 2 square roots that are being divided, you can put them under the same radical and reduce the fraction. But again, if you notice that one is a perfect square, leave it, take the square root of 9, take the square root of 9, which is 3, and then work on the square root of 72. Is there a perfect square that goes into 72? Yes, because that is not simplified, okay? This was a perfect square. But there is still a perfect square that goes into 72. So you're going to separate the square root of 72. Now, most of you might do 9 times 8, but hopefully you're starting to realize that 36 is a bigger perfect square that goes in there twice over 3. And then give them their own square roots. Again, either write it out separately or just write square roots over the top. And the square root of 36 is 6 square root of 2 over 3. Now, here's one thing we might not have encountered yet, okay, because we weren't working with these. So now, look at this part right here. You can actually reduce that just like you would a fraction. 3 goes in here once, 3 goes in here twice. So your final answer is 2 square root of 2 over, actually that's just the answer because we got rid of that 1. All right, moving on. Neither in number 16, neither of these are perfect squares. These are not perfect squares. So I'm going to put them under the same radical. 45 divided by 5. Well, 45 divided by 5, that's just 9. And the square root of 9 is simply 3. So a lot of these work out pretty nice, okay, if you just sort of follow the rules. And it seems like there's a lot of rules, but key in on those perfect squares. So I'm going to host a Zoom session tomorrow. So Zoom in if you're struggling so that we can walk through some problems. And then next week we'll do one more piece with simplifying radicals called rationalizing the denominator. And then we're going to review and get ready to test. So you can also email me questions or message me questions and I can try to help you that way as well. So have a great day. Stick with this. I know it's tough. I would actually even try to redo some problems that were already done so that you can try to just understand this process since it is new and abstract. Have a great day.